All right, everyone, if we can be seated, we're going to have a couple other breaks to allow you guys to get to know each other better. Um, I am really, really pleased that I to introduce to you Spencer Glendon, who unfortunately can't join us in person, but will be on video in just a minute, and we will have some time for Q&A with him. I have found that Spencer is not as well known to legal audiences, but when I say that he is a luminary in this field, particularly of climate and climate finance, I am not overstated. This is not hyperbole, and sometimes I do engage in hyperbole, but this is not. Spencer has advanced degrees in industrial engineering and economics. He has also been trained in finance, history, and languages. And he is well known in the climate space because he spent 18 years at Wellington, where he was not only the head of research, but he was also a macro analyst for them. And as you probably know, Wellington manages something north of $1 trillion. And so he early identified climate and climate risk and has really now spent the bulk of his career really tying all the threads together between climate and finance so that we hopefully have a world left. I first heard and then met Spencer between 13 and 14 years ago down at Stanford Business School, where what he said changed my world and changed how I looked at absolutely everything. So I was just thrilled when Berkeley reached out to Spencer, and Spencer agreed to join us today. So I'm going to turn it over to him.
Thank you, Suze. That is beyond flattering. And I want to thank the organizers for letting me do this remotely. I'm in Boston. And please don't let my lack of attendance in person signal lack of enthusiasm, because I am so excited that this conference exists. In fact, this is a conference I've looked forward to for probably 10 years, long before very many people on the Berkeley campus knew it was coming. I was looking forward to it, and so hopefully I will not disappoint today. So I'm going to share my screen. All right, I'm going to get going. I'm going to assume this is working. So as Sue said, I used to be the director of research at a big investment firm, and I, in that capacity, have done a bunch of different things. All right, I got a thumbs up from the squad over there in BAV backup. Thank you. And I could tell you all about that, but I just want to start with somewhere I was recently, which was at a conference. I know you go to conferences in hopes that people will tell you about other conferences, but this is a conference I think will interest you. It was here. It was in Park City, Utah. There's a picture for those of you who haven't been there before of what Park City, Utah is supposed to look like. It's beautiful. You can see why people go there. It has this warm glow and surrounded by all this snow. And I was invited by JP Morgan's investment bank to speak to 70 real estate CEOs. And they were unaware that I was coming or that I would talk about climate change. And it became pretty quickly clear that no one had ever talked to them about climate change before in this way. And I thought we could use Park City, Utah as an example of a place to start because it was useful during the conference. When I arrived, you see, it didn't look like this. Instead, it was gray and it was raining because although it was mid-January, it was 45 degrees outside. And that should have been a surprise, or shouldn't have been a surprise, I suppose, to some, but it was very surprising to the people there and frustrating. But I now want to show you that they shouldn't have been surprised. So what you see here is a map. And on this map is an area there. You can see Salt Lake City is in a bright pink. There's a darker pink to the right of it. This is a map from probablefutures.org. Probable Futures is a nonprofit initiative I started. And this is the number of nights in an average year when the temperature stays below zero. Okay, so they're called frost nights, technically, real technical term. And what I wanted to orient you to this map because we're going to do some different things on maps here. So the top left, you see maps of temperature, frost nights. And then to the right of there, you see warming scenarios, 0.5 degrees, and there's like a purple caret or indicator underneath 0.5 degrees. And that's the past. So that's the temperature of the late 20th century, 1971 to 2000. And what you see here is the climate of these places during that time. And I've clicked on Salt Lake City. In fact, I've clicked basically right where Deer Valley is. You see there's a box there. Those boxes are 22 kilometers square because the Earth isn't flat and we're on the northern hemisphere. They look rectangular, but trust me, it's actually a square. And in an average year, when the temperature of the atmosphere was 0.5, there were 171 nights below freezing. But what you see here also is there was a range. Some years they were only 105, other years as many as 234. And those are actually the 5th and 95th percentile. So those aren't even the tails. This is a place that had pretty wide outcomes with an average of about 171 nights below freezing. But we're not at 0.5 anymore. What happened when we went from 0.5 to 1? You see that number dropped. And I'm going to go back so you can look at it again. Look at the warmer year go from 105 down to 83 nights below freezing. And an average year went from 171 to 161. And the cooler year went from 234 to 228. This is what climate change is. This is the climate at 1 degree C of that place. Climate is ranges, and those ranges are changing. Now, last year, we were at 1.5 degrees, and actually probably a little over 1.5 while I was in Salt Lake City. At 1.5, you lose even more days. Now you see the colors on this map start to change. This is not a great environment for having the amount of snow that they want to have in Deer Valley, in Salt Lake City. But it's not just about cold, it's about days above 90 degrees Fahrenheit. Hot days. Didn't used to be hot there very often. So this is now, again, the number of days above 90 degrees Fahrenheit. In an average year, it might happen a couple times, might not happen at all. And then in warmer year, maybe it's a couple weeks. That was what it was in the late 20th century when the Stein Erikson Lodge was built, the luxury place where the boondoggle for CEOs was held, to which I was invited. What happened as it warmed? Well, 90-degree weather got a lot more common. At 1.5 degrees, more than a month is likely in a warmer year. In an average year, it's 9 days. You can melt an awful lot of snow with temperatures like that. And so you can see what happens as we get up to 2 degrees C, it's even more. Now, I want to be a dutiful academic. I have a PhD and haven't used ugly academic graphics in a long time, but I want to bring some here to the audience so it feels authentic. And I'm going to quote a paper that was released exactly during the week when I was in Park City there. And it's from 2 scholars at Dartmouth, Gottlieb and Mencken. And this is part of the abstract. And I know this is dense, but I want to read it. Most crucially, we show a generalizable and highly nonlinear temperature sensitivity of snowpack, in which snow becomes marginally more sensitive to 1 degree Celsius of warming as climatological winter temperatures exceed -8 degrees Celsius. Such nonlinearity explains the lack of widespread snow loss so far and augurs much sharper declines and water security risks in the most populous basins. What does this mean? It means that snowpack is safe until the average winter temperature is -8 degrees C or 18 degrees Fahrenheit. And after that, you start losing snowpack at a nonlinear rate. Let's look at Utah. So the way this map works here, this is average winter temperature, the exact variable in that paper. And the green is safe snowpack. It's colder than -8. What you see is all the green in Colorado, the green along the mountains there outside Salt Lake City, green up in Idaho and Wyoming. That's the past. At 1 degree and 1.5 degree, you get on the wrong side of that. And Utah is now irreversibly losing its snowpack, faster and faster, in fact. And as we warm to 2, and if we get to 2.5 or 3 degrees C, there's basically no hope for snowpack in much of that area. And this is not just a problem for the Stein Erikson Lodge or JP Morgan or the boondoggles. It's a problem for water supply. It's a problem for agriculture. Utah is dependent on snow. Utah, in fact, trademarked the greatest snow on earth as its state motto. It's what's on the license plates. It may make you wonder, why did they assume it would stay that way? Sure, they had snow for a while, but why would it always be snowy? Because climate didn't change for 12,000 years. There was no conference at Berkeley. Even if Berkeley were a 12,000-year organization, there wouldn't have been a conference like this for 12,000 years because the atmosphere was stable. This is a graph of the average temperature of the atmosphere going back to 10,000 BCE. And what you see here is a very wiggly line in a very narrow band. And I've chosen this time frame because this is the period of civilization. The first human settlement started in 9500 BCE. Before that, there were no known human settlements. And then we cruised right along in that green band with barely 1 degree C of volatility. That made life awesome, easy to plan, easy to know what to expect. What about before 9500 BCE? Not so easy. And in response, humans were mobile. It's the same graph, but extended back 1 million years. Humans first emerged around 200,000 years ago, and they did not sit still. They did not settle. They did not decide to stay in one place because the climate was volatile. In response to volatile climates, people move. So we have these two periods. Humans were mobile, humans were settled. And what that teaches us is that a stable climate is the foundation for building community in place. If those communities stick around long enough, they develop a culture. Cultures then coalesce into forms like governments. And that's where all of you come in. Eventually you get legal infrastructure, physical infrastructure, rules. That allows industry to blossom. And eventually you can have really fine specializations like ESG specialist. This all rests on a stable climate. All of this. I worked in finance for a long time. People in finance think that it is the foundation of society. Oh no. It is at the very top. It is the luxury of having all of those other things in place. And that climate of civilization was perfect for humans. There were large expanses of temperate land, stable seasonal patterns, and nowhere was too hot for the human body. Nowhere on Earth. So you've gotten used to these maps. This is the past, 0.5, the late 20th century, and what you see is all gray. This is 32 degrees C wet bulb. This is 90 degrees Fahrenheit, 100% humidity. Above this temperature, even the healthiest human has very, very difficult time surviving. This is extreme danger. And what you see is that this doesn't happen anywhere. Everywhere is gray. So for those 12,000 years, nowhere on Earth was too hot for the human body. But now we are outside those bands. There are 4 periods that are relevant for us. Too hot for humans, too unstable for settlement, the Goldilocks, and now. And now we are outside the bands of civilization, going up. And this needs to prompt us to think, what are we going to do? How are we going to live with this? We're not going to solve climate change. It is already underway. We are unprepared for where we are now. So talking about solutions is important, but talking about how we're going to live with it is at least as important. So as Sue said, I spent 2 decades in economics and finance, and the best models in those professions are slightly better than throwing darts. If you have a model in finance that is right 60% of the time, you are George Soros. In fact, actually, George Soros's models are worse than 50% of the time, but he has a good slugging percentage for those of you who are Moneyball freaks. But climate models have been right for 40 years. When I discovered this, I realized humans actually had made one really good forecast and no one was using it. What did they say? They said it would be more hot, humid weather. Drought and deluge would increase. Temperatures would rise faster near the poles. Seasonal patterns would change in predictable ways. There would be less mild weather and more extremes. All of these things were said more than 40 years ago. All of them have been true. And the thing is, everyone is actually using a climate model, but almost everyone is using an obsolete one. They're using a bad, precise climate model, which is that nothing will change. What do I mean by they're using them? Well, all the storm sewers were built for a historic range of precipitation. Power systems were built for historic temperature ranges. Residences were built with architecture and style and design for a range of temperature, often to keep heat in rather than keep it out. Our customs in those cultures, like when we have vacation, what sports we play, what we celebrate, all based on past seasonal temperature patterns. And all agriculture is dependent on steady, predictable patterns of precipitation. And For Californians, homes weren't built to have air filtration. So we need to use better models and better data. Climate stability really gave us this idea that if we had the 1 in 100 year past, we knew the 1 in 100 year for future. But backward looking data and standards are now a problem. And I really hope that this audience can help solve that problem, because climate instability at the bottom is already causing instability all the way up. I'm going to give you an example. The federal government produces these USDA plant hardiness zone maps. This tells you what you can plant where. I happened to speak just 2 weeks ago to the Garden Club of America's leadership. These are their templates. In fact, people at that conference sit around by their zone. They stand up and say, I'm Spencer from zone 6, or I'm Susan from zone 7A. People are identified by their zones because those zones were meant to be perfect matches for where people lived. They were going to talk about what constitutes an indigenous plant. But this map had to be updated in 2023. It was last updated just 11 years earlier, but the map was obsolete. So now we have these new maps, hooray. Except that the 2023 map is already out of date. Why? Because the policy for creating these maps is that you take the last 30 years of data and you take the average of those 30 years. And we are now at 1.5 degrees C, but the USDA is telling gardeners that we are at 1 because they're looking back on average 15 years and giving people the wrong zone. All of the zone maps are wrong. So let's look at a particular place. Texas is home to the biggest pecan farms in the world and some of the biggest server farms. Nice up close picture of pecans. Pecans need a certain climate to thrive. And that's what they used to have here. So this is the likelihood of a year plus extreme drought. Used to be a 5% likelihood here. Now a drought is defined locally. So a drought in this place is different than one in Las Cruces, New Mexico, which is different than one in Baton Rouge. But in this place, what was a once in a generation event, 5% chance, had those odds. But when we go just to 1 degree C, those odds go from 5 to 9%. That's a very big difference. And what you can see is now there's this pea green color, where in those areas, the extreme drought is now a 5 to 10% chance. An every 5 to 10 years chance. At 1.5, now it's an every 6-year event, if you want to think about it in periodicity. 16% of the time is not an extreme drought anymore. It's aridification, and it's already a problem. And you go to higher degrees of warming and you see what a problem it is for these water-thirsty plants and the aquifers down below. So I'll move through 2.5 and 3, but now get to heat, days above 100 degrees. Pecans hate really high temperatures, and that didn't used to be that big a problem. Days above 100, on average 3, many years none. Some years you get a couple of weeks. But this has changed radically between 0.5 and 1 degree C, where now you might get a month of it, and an average year is what used to be extreme. Pecan farmers are desperate. They are really struggling. And the chances for pecans in the future are just very low. There just won't be pecans growing there. And it's not clear where they'll be growing in the future, because those climate conditions used to be there. They don't really move exactly to somewhere else. So what makes it an indigenous plant is an interesting question. But this isn't just about gardening. It's about the insurance for those farmers, because USDA hardiness zone maps are the basis legally for crop insurance for all crops. And in fact, it's currently illegal to use climate model data to set property insurance rates in many states, including the one you're in. Only past data is allowed. So climate change isn't just about warmer temperatures. It's about all kinds of instability. And I now want to bring you to something that I think about a lot. My PhD is actually in economic history and urban economics. And I've thought a lot over the years about how a state economy or local economy is supposed to work. And this is the canonical model. This is what all of the people in all of whatever city you live in, whatever state you live in, this is how we think about it. There's something nice about the place, has something attractive about it. So people built a government, a community and a government there. The next thing that happens is governments and borrowers, developers borrow money. People migrate there. Everybody's trying to attract people to move to their place. In-migrants then borrow again from the market, 30-year mortgages. And that repays the government and the developers with their sales, the fees, and the taxes. And you just repeat 3 through 6 forever. That is plan A. That is the plan. But I think it's worth thinking about how that plan can go in reverse, because there are going to be a lot of lawsuits about this, because the municipal and state bankruptcy rate is going to go sky high because of the following. What first happens is aging and failing infrastructure and social programs require more spending. Well, that means governments have to increase tax rates and fees. And now this place that seemed attractive, well, maybe it's not quite as attractive, and that puts pressure on property prices and in migration. People leave, and the rich usually leave first, which means that their property, that the most valuable property falls in value the most, and then government revenues fall, which brings us back to number 1 through 6. You repeat that forever. This may seem abstract, but it's already underway in a big place, which is Florida. So Florida is the fastest growing state in the United States, and it is an interesting place. As you can see here from this image, it's in this area that's really more like the Bahamas than it is like Georgia. It's a peninsula that's made on porous limestone. And that porous limestone is interesting because it allows water in. Moreover, Florida's recent development is increasingly coastal. Municipalities depend on property tax. Remember, there's no income tax in Florida. So property is very important. Yet infrastructure is very new, which means that maintenance isn't in the budgets. If you look at municipal budgets, they don't include maintenance, let alone repair or replacement. But the warmer ocean powers bigger rainfall and fiercer storms, and higher ocean pushes into Floridian land, aquifers, and sewers, and the weather is getting hotter and more humid. So what are the markets that hold Florida together? Well, the first is that actually home insurance is a prerequisite for mortgages. Even though mortgages are 30 years and insurance is only 1 year, if you can get insurance for 1 year, it's assumed you will get it for 30. And so there's a mismatch. Also, you need conforming Floridian mortgages to be bought by Fannie and Freddie. Ratings agencies have to endorse the municipal bonds. The federal government has to bail out Florida after the storms. People need to continue to move to Florida in large numbers. And investors outside of Florida need to keep lending to cities and citizens. So what's already happened in Florida? And we could do this exercise for California, and we'd get some interesting similar results. The first is that reinsurers and catastrophe bond markets have completely dried up in Florida. There is no bid. So big insurers are pulling out, and small ones are liquidating, but they can only pull out very slowly, which is why the small ones are just liquidating for regulatory reasons. In response, Florida's government has created its own insurance company and its own reinsurance company now. And we know from data that banks are disproportionately offloading Floridian loans to Fannie and Freddie. So the government's portfolio is getting worse. In the meantime, cities are starting to undertake massive new capital projects, like raising all the roads. And we know from annual reports that Disney's becoming a seasonal business. Summer is its biggest season in Disney World, and yet we know from annual report last year that traffic is down because children and adults in fuzzy suits don't do so well in hot, humid weather. Which brings us to toilets. And I want to tell you about 2 conversations I've had. One is with Jeb Bush. It was back when he was running against President Trump, or then to be President Trump. And I asked him, you governed a long peninsular state. What did you do about climate change? And he said, well, the problem is the toilets. And I said, do tell me more about these toilets. He said, well, every toilet in Florida flushes into the ocean. And as the ocean gets higher, it pushes back. And so what's going to start happening is that the sewage systems are going to start going the wrong way. And the aquifers will get infiltrated and the land will get infiltrated. That's a big problem. I said, what'd you do about it? He said, nothing. We did nothing about it. Well, I'm curious, why not? He said, because it was never anyone's number 1 priority, and we only did things if it was somebody's number 1 priority. What should you have done? I asked. Well, we should have changed all the building codes, but we didn't. Which brings us to just a few months ago. So Probable Future is a climate literacy initiative. We got a call from a big municipality in Florida, and they said, we would like your help. We said, sure, what would you like help with? They said, well, we have a problem that there's lots of money available for resilience and adaptation in our region, and no one's applying for it. I said, okay, we can probably help with that. They said, no one seems to understand that they're at risk, and we want to help them understand that risk so that they apply for federal programs. I said, great, that seems like the kind of thing we can do. I said, there's just one catch. The RFP is very specific, which is no one can leave. So what do you mean by that? Well, we need you to understand that we want people to be just worried enough to do resilience and adaptation, but we don't want anybody to think they should leave our area. We said, we don't have a strategy like that. Sorry, we can't calibrate the amount of climate fear that people have, or climate worriedness or preparation. They said, well, then we're not interested. And they moved on. I don't know if they found another provider of this magical information, but it tells you where we are in this process. People need to be just worried enough to do something, but not so worried as to get out. So what are the outcomes, the climate outcomes that matter most? They are wet bulb temperature and drought. Basically the limits for the human systems and the limits for agriculture and plants in general, nature in general. And this is where a little climate literacy can go a long way, which is something you should carry around with you. Every 1 degree C warmer that air gets, it holds 7% more water. It pulls it from the ground, it can hold it longer, and that compounds. So air that's 10 degrees C warmer can hold 100% more moisture. And that's why wet bulb temperature is rising faster than temperature. So I've ratcheted this down to 28 C, which is 82 degrees and 100% humidity, or 100 degrees Fahrenheit and 45% humidity. What you see is this is like the hottest, grossest day in Orlando or Houston in the late 20th century. Green is 1 to 3 days. The blue, the darker blue, is 4 to 7. Then you have 1 to 2 weeks. Then you have 2 weeks to a month, and then you have more than a month. What you see is that Bangladesh, Northeast India, and some areas in Pakistan were among the hottest places on Earth. But generally, this happened very infrequently, less than a week pretty much everywhere. But that's already started to change. And by 1.5 degrees C, Houston now looks more like parts of India did. Parts of India look, a lot of them look like Bangladesh, and Bangladesh doesn't look like anywhere ever before. And there's huge change in the Amazon. And this is dangerous to be outside, dangerous for lots of people. This has consequences for all kinds of public health and construction and agriculture. And if you go up to warmer and warmer temperatures, the world becomes unsafe for many, many people to live in. And the consequences of this are not trivial. And we need to be thinking about what those consequences are, and we don't have good models for thinking about it. But remember, those models can tell us where there will be more drought and more deluge, where there will be heavy rain and where there will be dryness. And dryness, drought in particular, is a great predictor historically of migration. And so this is the change in extreme plus drought. It's this year plus drought. It's the same metric I showed you for the pecan area, but now I'm showing you more generally. What I want you to see at 1.5 is how many of the Mediterranean zones around the world, the Mediterranean coast itself, Southern California, parts of Mexico, South Africa, the parts of Australia that are so nice or were so nice. What's happening is they are becoming squeezed. Those are often between a desert and an ocean, and the desert is squeezing them out. Crossing over to 2 degrees C, what's happening in Europe actually is that the Sahara is moving into the Iberian Peninsula. So I don't want you to get too worked up about this. I want you to understand it and incorporate it and understand what models around you, what assumptions around you are not incorporating this information. And one of them is the obsessive focus on decarbonization. Obviously, decarbonization is of primary importance here. Those maps should motivate it. But thinking how much decarbonization actually depends on preparation. When I'm invited to speak, my colleagues are, we are often the only people who actually talk about climate change at a climate change conference. Other people talk about decarbonization, which is great, but isn't climate change. And I want to impress upon you how important physical climate risk is, even if all you care about is clean energy, because clean energy assets are the most civilized form of civilization ever invented. They're complicated. They require agreements, monitoring, commitments. They are networked. They depend more on clear legal frameworks, peace, stability, and sharing than almost anything humans have ever invented. And so we need the rest of that tower to hold together. And adaptation enables mitigation. Without it, you will not get the mitigation. If you have a singular focus on decarbonization and not on maintaining communities, cultures, government, infrastructure, industry, if not connecting those specializations, you will not get decarbonization. Climate does not should not reside in some remote part of a business or some specialized sustainability group. It is holding all of this together. And so I want to encourage you to think more like a gardener. I brought up these gardeners before because gardeners have paid attention to the physical world. And I'm embarrassed to say that it wasn't until I was well into my 40s that I really paid any attention to the outside world. I was interested in abstractions and rules and technology and laws and numbers. But there were people like Mary Oliver who were paying attention to the physical world. And that's what we need to start doing, because stability enabled complexity. And if we want to keep that complexity, we're going to have to mind things ourselves. What does complexity look like in a garden? It's all of these things together. That's how you get a lush garden, get a healthy crop, get a healthy ecosystem. Fossil fuels are the opposite. They're anonymous, they are portable, they are energy dense, they are the fuel of a low trust world, and they are invaluable in war and crisis. And so don't just think in terms of annuals, but think in perennials. Don't just think in terms of plants, but bushes and trees. Don't take your lead from agribusiness, which destroyed perennials and complexity. And I say this because I understand what happened in finance and business, which is that 40 years of bull markets changed the meaning of risk. Everybody wanted to be a risk taker. Moving fast and breaking things was cool. Disruption was a virtue, whereas maintenance, repair, and preparedness were for chumps. And so I want to offer a little framework here that can be helpful to you, and then show a couple of examples before I conclude. Think in terms of risks. The first order risk is just what happens. Is it hot? Is it wet? Is it dry? Is it on fire? The second order is what happens as a result of that to human health, to plant health, to systems, energy, agriculture, industry. And then think through the third order. How do people react to those changes? Markets, rates, political power, unrest, behavioral change, legal change, lawsuits. I'm going to give you a little example here. So in Portland, Oregon, in June of 2021, it was hot. You all remember this. Big headlines, unbelievable was the way it was described. And yet it was totally believable. This is just our data. Our data comes from global models around the world, brought into this framework, brought into a way that you can all see it, but this is behind the scenes. And those three carrots on the right are those three successive hot days. And when the world was at 1 degree C, this was the expected distribution of summer days in Portland, Oregon. And yes, these were hot days, but they were not incredible. They were at the end of the distribution. What you see is if we go to 3 degrees C, they won't even be really at the end of the distribution. And if we get to 3 degrees C, look where the end of the distribution is. That's 50 degrees centigrade. That is extraordinarily hot. So what happened in the second order? People suffered, moved into cooling centers. All kinds of infrastructure was destroyed. And lots of agriculture suffered. So what's the third order? Well, the city announces we are going to deal with this by installing 15,000 low-income housing units, getting them air conditioning. A year later, only 100 had actually been installed because of a shortage of HVAC experts, electricians. thinking through these systems and their preparedness or lack thereof is going to be really important. And I want to give you an overseas example, which is London. It's mild, right? In fact, economic models say climate change will increase UK GDP because winter will get shorter and winter sucks. Well, here's what happened in London, England. 2 inches of rain fell in a matter of hours. That is a month's worth of precipitation there historically. See, historically, London rained often, but never hard. And when that happened, there was a flood. Into hospitals, into subways, train stations. So what happened? Exacerbates the housing crisis. The mayor says you need a lot of new units, but flooding is causing the city to lose housing capacity and not gain it. And now I want to take you to something only a nerdy lawyer could like, which is the minutes of the London Assembly, the local government. It's a meeting, June of 2023, with the mayor and a member of the assembly, Anne Clark, is asking questions of the mayor. So what happens in this back and forth? Well, Anne Clark says residents living in basement flats have told me how the risk of flooding has left them unable to get insurance and has rendered their properties as unsellable. What steps can you take to help? The mayor says it's clear that some London homeowners do struggle to access insurance. I do not have powers in this area. The government must take action. The lack of access to flood insurance is more prevalent in urban areas. The first port of call for such residents is the Flood Re scheme. This is a government-based reinsurance scheme that covers all forms of flooding. This includes many apartment blocks and large subdivided residential buildings. Anne Clark asks again, I'm just wondering what resilience plans the London Fire Brigade has in place to deal with flash flooding of basement flats this coming summer. The mayor again, yes, thanks for raising that. These are biblical events happening every year or every other year. Also, in the past, as a country, we have discussed coastal floods and river floods, but never thought about floods in urban areas or flash flooding caused by hard surfaces and so forth. We have to do something. The London Fire Brigade needs new kit. We have given them new kit. When you join the fire service, you do not think about the need to work an inflatable boat or buy inflatable boats. We are doing that. We have that. This is the kind of boring stuff that is the difference between being prepared and not being prepared. And then there's this. The number one place where immigrants are coming to London from is Bangladesh. And so this is days above 30 degrees, dangerous, dangerous weather at 1.5. And what you see in Bangladesh is the prevalence of this extreme heat. And it shouldn't be a surprise, even though it's far away, even though the people are poor, that this is the number one source of out-migration into the UK. So the punchline here is, if climate isn't in your story, it's science fiction. This is from a writer and producer of The Handmaid's Tale, but stories aren't just in entertainment, they're in all of human life. You are all storytellers. And so we need to tell better stories, especially Californians, because Californians tell some weird stories, some peculiar, fantastical stories. Here's the one Silicon Valley tells on the left, everything's going to be fine. And on the right, it's apocalypse. That's Hollywood's story. Or you have Mars and Earth. But we can live well in a changing climate, but we need good lawyers to do so. So duty of care standards need to include physical climate risk. Clean infrastructure needs to be climate ready. Oops, this wasn't supposed to look this way. Sorry. Regulations need to be forward-looking. Staff, boards, and stakeholders need training. Migration frameworks are unprepared. Migration politics even less so. And the municipal and emerging market bond markets are perilously ill-informed. They are really among the very worst. And so I'll end you with this. I'm old enough to remember when there was somebody called a webmaster at every company. Just one guy, it was always a guy, and he was in charge of the internet. And that seemed sufficient. Then maybe there were a couple people, but gradually we figured out that actually technology, information technology, was part of everything. And so we need to make that transition happen. And you don't need to change your job. You just need to bring climate into whatever job you already have. So thank you. I'm happy to take questions. and offer you a chance. If you want, you can point to this website or to the QR code there to connect with Probable Futures. And now I'm going to check the chat.
Thank you so much, Spencer. We are unfortunately at time, but please do
Okay.
reach out. I personally wish we had more time because I have so many questions for you. I think you've left us with a lot of thoughts, a lot of urgency, and I think you're going to shape a lot of the discussions that are about to come. I'm hoping you'll stick around for those. But we are now getting ready to announce our next conversation. But before we do so, could we please give a very hearty round of applause to Spencer for all the extremely useful information?
Thank you.